Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to another episode of As the Black Hole Spins. Oh, affectionately called.
Do we
spin? They do spin. They think they spin.
They think they spin?
Yeah.
But do they really spin?
But do they spin?
I need to go speak to my friend Dr. Stephen Hawking on that one.
No, you do that. You're listening to the Event Horizon on Astronomy.FM radio, everybody, by the way. This is another Friday evening, December the 15th, 2017, 9 o'clock in the evening for those of us in the eastern portion of North America, also known as 2 o'clock in the morning. Oh, that's early. Saturday morning, December the 16th, 2017. My name is Marty Kunz with my co-host.
Good evening, it's Nick Evetts. 2 Whiskey 0 Lima Uniform November, or 2 Echo 0 Lima Uniform November. It's all too early!
It's not too early.
Well, it isn't if you're living in the Eastern time zone, but...
No, that's true. And, of course, we have our chat room open. Well, it's open all the time.
Get in the chat room, everybody. Take part. Enjoy the show. Ask us inconvenient things.
That's right. But if you wait till we stop talking, then it will read it. But if we're talking, we don't read it.
Well, that's not strictly true, you know, because we have Starstorm with us,
Yep.
and Starstorm is very good at leaning over, grabbing my piece of clothing and pulling on it and pointing at the screen, going to say, "Oi, someone's asking a question, aren't you, Starstorm?"
Mm-hmm.
She's got her earbuds in.
There you go. So we got you and me in chat room. We got Intensity, Affinity, I think it is, Starstorm, and Glenn. Hey, everybody. A couple of people like playing with the type style, so it's a little hard to read sometimes.
Yeah, I'm getting closer to Affinity or something.
Affinity, yes.
Affinity. Well, if you please,
Infinity would be good. Intensity and Infinity.
Infinity and beyond.
There you go. Those are the names of people in our chat room right now. So come on over. Go to the homepage where it says look where it says radio chat. Just click on that and type in a name.
And I want to send a very special shout out to all my friends at the Bangkok Planetarium.
Where's that
at? Thailand.
Okay.
Because we do actually get the show listened to on podcast in Thailand.
Nice.
It is very nice.
Mm-hmm.
Actually, saying that, the main reason I thought to give them a shout out, apart from the fact I like like everybody there, is the fact that they asked me a question whilst I was at work this morning.
Mm-hmm.
Do you know, one thing about being a Time Lord is you always get your time tenses muddled up, don't you?
Mm-hmm.
Anyway, they asked me a question because there was a NASA briefing today, and it's basically NASA have said very point blank, Kepler is toast. It is finished, had it, knackered, deceased.
Oh, I thought that was a given a long time ago.
Well, yeah, okay. So basically, what's happened? Well, they've only actually really let the story's only really getting out. Basically, last week, NASA dropped a bombshell that its Kepler mission, the greatest planet-finding mission in history, had teamed up with Google's AI to make a groundbreaking new discovery. Just 1 second, and I will get a link into the chat room. I haven't forgotten you, chat room.
Well, they're still using the data from Kepler and making new discoveries, actually. So, yeah, let's talk about that new planet that somebody mentioned. Did you hear about the new planet they discovered? It's like, well, they discover new planets all the time. Yeah. But people don't know which one it is. And
well, what it is, the really big deal is that Kepler 90 is the star system that's known to have 7 planets, it's now got 8. It's like our solar system. We went from 9 to 8. And then someone says, well, you know what? All those other trans-Neptunian objects can't be planets, which, of course, led to them demoting Pluto, which is totally immoral in my book. I'll never get voted onto the IAU because of that, I'm sure. But no, it's not fair to Pluto.
I don't mind that. It's just a rock. I mean, an ice ball.
But you know what? It's a nice, pristine chunk of solar system real estate that really could really do with more. Oh, hi, Uptronics. Nice to see you, mate. Evil Spock's coming to chat. Great to have you in here. So anyway, what makes Kepler 90 the only system known to have as many planets is that it's how thoroughly the Kepler data has now been examined. Despite headlines you're going to likely see in the future, bet on this. All of Kepler's major discoveries are in the past.
Yes.
So the Kepler 90 system, even before the discovery, was objectively an interesting one. It was first off, it's a G class, same class as our sun. The orientation of the solar system is perfectly edged onto our own line of sight, with its plane of the solar system orientated towards at a position of less than 1 degree. When we look at the main star, each time a planet makes a complete orbital revolution, we see the star dim due to the transit effect. This is how Kepler finds its planets. He's looking for periodic dips of equal magnitude in the brightness of a star, corresponding to a planet at a certain distance and size. So, follow-up observations are then undertaken to confirm the planet's existence, moving the robust Kepler discoveries from the category of candidate planet to full planet. Now,
this was a tough one, though, because it's a really small planet. So they had to do a lot of extra work to figure out in a lot of in static. It's like trying to pick out something out of an image in static.
Yeah.
Or a song in static, stuff like that. So that's kind of what it was. They had to analyze this data really, really well, and then they found a regular pattern that was really faint and determined it was regular enough to classify it as another planet in the system. Okay,
so what we're doing, we're looking at the 3 innermost worlds are comparable to the physical side of Earth, ranging between 18 to 32% larger. They're all incredibly close to their star. They complete an orbit in 2 weeks or under, with the closest one orbiting about 7% of the Earth-Sun distance. The next 3 are all closer to Neptune-sized worlds, approximately 2.5 to 3 times the radius of the Earth. Surely they are gas giants and have gas envelopes and orbit at distance comparable to that of Mercury or slightly beyond. The 7th planet was discovered by a rarer and more sophisticated transit time variation method, and is actually enormous, 8 times the radius of the Earth, or nearly as large as Saturn, orbiting at the distance of Venus. So, through the use of machine learning techniques that Google pioneered, they're able to extract the evidence for one more influential world, one larger than Jupiter, and orbiting at the distance of the Earth. Now, applying the same technique to Kepler 80 system, they've also found another world there as well. So that has now got 5 worlds.
Okay.
So, yeah, it's a kind of goodbye Kepler probe, but hello data mining.
Exactly. That's why a lot of discoveries are actually made after the fact, like going back through the data over and over and over and over again. Yeah. The star is about 2,500 light years away in the constellation of Draco, by the way. It just has, the Kepler 90 was that the 90th star or the 90th system discovered, or I wonder what the 90 stands for in this one.
Well, I'm going to go back to the article. This 1 second. I'll have
to look at the whole Kepler system up and see what the each designation actually means. What's the parameters for the number of that particular star? So the star is not called Kepler 9. It's a star, a 90. It's a star in Draco, which would have a designation, usually just a coordinate designation. But the Kepler mission has got its own designation for this star. So yeah, all 8 planets are within the orbit of the Earth, so they're all really close to to its star. The one just discovered is can't remember the miles away, but it's only got a 14-day orbit, so that's really close. Probably rocky, and it's cooking hot, kind of like a Mercury, but even closer, like 4 or 5 times closer to the star. So not a great system for looking for life unless there's still smaller planets farther out, which at a little bit more comfortable zone, but probably not. They got a really big Jupiter at about the distance of the Earth. That's probably disrupted the orbits of other planets, smaller ones that might be farther out. It's probably sent them out a little farther. It might make them a little too cold.
Well, the great thing is, what's going to happen, that there are future missions in the pipeline. So they are poised to take the next great leap in planet finding and to learn more about them. The James Webb Telescope will allow direct imaging of large, distant exoplanets and potentially measure the atmospheric contents of worlds only twice the diameter of Earth. WFIRST will be even more successful at planet hunting than Kepler was, and if it launches with a star shade, it could look for organic signs on Earth-sized planets that are close enough to our own world. There are big breakthroughs ahead, but they're on the relatively distant horizon. So it's been a decade since Kepler began operations, and whilst it's revolutionized literally the number of planets and our knowledge of planets in the universe, we need new equipment and better data to push forward our understanding. Fortunately, the next planet finding mission, TESS, will be inexpensive. That's under $100 million. Very expensive for a satellite mission and unambitious. Just a wild field and low depth version of Kepler, measuring the light from about 3 times as many stars for a period of 2 years. But there are better advances to come. But Kepler has already seen almost all of what's going on. Practically all the great science we hope for has already been extracted. It is time for the next step. And it's getting boring speculating about what could be out there. It's time to know. Now, this was actually written by astrophysicist and author Ethan Siegel, and he's the founder and primary writer of Starts With a Bang, and he's also wrote books called Technology and Beyond the Galaxy as well. So we have the chance now with future missions to really do something. And if the star shade concept does work, it will enable direct imaging of exoplanets perhaps as early as 2020. There's a concept drawing of a telescope using a star shade on the actual link we put into the chat room. But it's going to be fun. However, having said that, why are we just looking? Why aren't we doing the next best thing, which is exploring our solar system? We need to start exploring the solar system. We've got Mars. We've got the asteroid belt to visit.
Wait. Define exploring the solar system. What you mean?
Okay, by exploring the solar system is we have spent so much time using robotic probes. They're great. I agree. They are totally great. Voyager, Pioneer, the Venera missions. They've done an awful lot of groundwork. Viking also.
Space work, not groundwork. Only the landers did groundwork.
Okay, but they actually laid all the foundations.
There you go.
For manned exploration of the solar system. Now, if Lockheed Martin get off their backsides and actually get Orion working, we'll be going back to the moon. We're supposed to be going back to Mars, and then there's the asteroid belt.
Well, if you give them some money, I'm sure they'll do it.
Having worked for a defense contractor, I can tell you that they are sinkholes of money.
Oh yeah.
Yes, I like boots on the ground. And what about Pluto? Let's go back to Pluto. We need to go back.
Back to Pluto.
Yeah, that would be brilliant. I think you're going to need a really effective spacesuit to keep you from getting frostbite, or even worse, for a shattered foot and limbs. But you know what? We have to explore the solar system. We've done it in science fiction, and we've done it with science fiction rooted in science fact.
Dan Dare.
Well, yeah, Dan Dare, but more the BBC Voyage to the Planets. They built a spacecraft which is technologically possible. They have looked at all the issues of a long-duration space flight in the solar system, including solaration.
Technologically possible.
More so, yeah. With if you're looking at the Elon Musk parameters, Elon Musk, he's looking more at a Dan Dare Anastasia type spacecraft. I think what we have to do, and this is just my opinion, but we have to forget about doing it as one country. We have to do it as an international mission. Every country contributes towards the building of the spacecraft, the training of the crew, the equipping, the supplying for a long duration science mission in the solar system. Is it going to be hard to do? Yes. Is it going to be rough on the crew? Oh, yes. But then again, think about what the crews of the ships that circumnavigated the Earth back in the 16th, 15th, 16th, 17th centuries.
90% of them died.
Exactly. But the thing is,
that's not good nowadays. That's politically incorrect.
Marty, they wanted to go and see what was over the horizon. They wanted to be the first to say, we've been right around the planet, folks.
Well, they're hoping to make money off of it, too.
Oh, yeah, there was the financial incentive. If you were a British or an English, rather, at that point, sailor and captain, the idea was you were going to go and cause mayhem and etc. to the Spanish main in the process and get booty from the Dons and bring it home.
Or whoever did it basically got to claim new land for their own country. That was a good financial incentive to their king or queen, too.
Well, yeah, exactly, because that way you extended not only your country's standing in the world at that point, you also increased your economy.
So it would be better if we actually went out there to conquer new planets instead of explored planets. There'd be more incentive to do that.
I tend to think basically the conquer idea is well, what is there really to conquer? Because we know what's out there and we know what we need to do. And to be honest, the only thing we can do is colonize.
Well, and mine asteroids.
If we go out there to set up colonies, then it's going to be under an international system. Because I'm sorry, I hate to do this. No one country can afford that type of space mission anymore. Yeah, Apollo 1. You're right, Glenn. Apollo 1 did not stop the moon landings. Gene Kranz, when he was being asked in the inquiry to the deaths of the Apollo 1 astronauts, he said, well, you know what? I'll tell you what Gus, Virgil, and Roger would have said. Get her going. Get us to the moon. Let's do it. Forget about the fact we had a problem, but fix the issue. Then get on with the job. We knew it was a risk when we decided to strap ourselves in that whacking great candle and set it off. And that is the whole point. We know space travel is risky. Columbia and Challenger happened because we got basically blasé about space travel.
Well, that'll happen again when you start sending people to like all kinds of planets all over the place. Then that'll be like blasé too.
Yeah. Well, hi, Quiet in the Wood. Nice to see you come into the chat room. Thank you. Thank you for letting me know about that, Starstorm. But the thing is, though, people just because of the shuttles were going off nearly every 2 or 3 weeks, we got complacent. We forgot the risks, and that's why accidents happen. We started taking risks without thinking about it. They weren't calculated risks. They were just risks taken. They were wild risks. We should have thought better. We should have been better prepared and thought more about what we were going to do.
Hence the hesitation to just go blazing out to the planets when we already calculated it's too risky to do that. So that's what's holding back, people.
No,
space travel right now.
What's holding back space travel is the fact it's convenient for the incoming administration, to change NASA's direction. Every new incumbent tells NASA to do something different.
I think if it was
their budget.
If it was zero hazard to go there. We definitely would be going there now already, but it's not zero hazard. It's high hazard.
Well,
they still haven't figured out the radiation issue. How do you protect in a practical, affordable sense? We cannot go out there and survive because of the radiation. It's not a calculated risk. It's a calculated fail.
Well, the other thing is,
that has to get conquered first.
The other way you can look at it, if you want, is the fact if you bought an aircraft to fly from Detroit to Washington, D.C.
Or Detroit to L.A.
Or Detroit to L.A. or wherever, you're taking a risk. You get in a car, take a trip. You're taking a risk.
Okay, but if you
you're taking a risk.
If you fueled your airplane and it was going to run empty in air, guaranteed to crash, would you go on that plane? No. Well, if you go traveling out to the solar system, guaranteed to get killed by radiation, would you do it in the first place? No.
To be honest.
So there's difference between calculated risks and, like I said, calculated failure. So if it's guaranteed to fail, well, you better hold back a little bit until you can fix those issues, because those issues are out there. Now, like the early explorers didn't know there was health issues going across the water, so that's one of the reasons they went. They thought they were going to survive, but they guaranteed to sink.
Glenn has made a very good comment in our chat room. He says, put profit in there and it will get done.
Not necessarily. Profit's a good incentive, but health risks are less incentive.
Well, the thing is, life itself is a risk.
Well,
at the end of the day, that's why we have insurance.
Well, it's not. I think so. Let's move on.
Yeah, we're having so much fun. Okay, let's go on to something else. At the end of the day, I want to see us.
42.
42. Yes, there we go. 42. The meaning of life, the universe, and everything, and the life of a mini black hole. It's first created to when it dies. 42 minutes.
There you go. Nick, you can personally buy lottery tickets to finance your own space program. So you keep working on that project, and then let us know how it comes out at the end of the day.
Yeah. Earth calling, Marty. This is Mars calling. Hey, we're having a ball here.
Let's see what's out in space. Got a little solar wind stream because there has been some coronal holes on the sun right now. So another 2 more days. Arctic sky watchers should be on the alert for some aurora coming up. So no activity as far as sunspots. A little bit of active regions. No sunspots associated with it though. So, but there is some coronal holes. So there will be aurora in a couple more days. Did you see the Geminids where you were at? Were you snowed in like I was?
I was snowed in.
Yeah.
I had 1/4 inch of snow mostly. And basically, I went out this morning, misty, waning crescent moon, and Jupiter. See that? I had to use a Mark 1 eyeball.
I didn't get out the next night when it was clear, which there should have been still some Geminids going on. Heard it was a decent enough shower. I didn't hear about anything spectacular, but decent enough. I think it was a little bit overhyped, but there were some decent meteors, and I've seen some pictures of stuff, so it would have been nice to get out to. But like I said, I had a raging snowstorm, 6 to 10 inches, 9 degrees, 90 Fahrenheit that night. So, yeah. Not a good one to get out and do some meteor shower observing. That's okay.
You know what? That's a problem for us here in the northern United States. By the time we get some really nice meteor showers like the Geminids, it's winter.
Yeah, a bunch of other storms too. What did I have up before? I had American Meteor Society. Their homepage has got a list of about a good 6 meteor showers right now going on along with the Geminids. So there's still some Geminids out there, but there's a bunch. Somebody was reporting that they were seeing meteors coming from another direction. And yeah, there are other meteor showers going on. So check out American Meteor Society and their homepage. They give you basically a list of 1 or 2 weeks of meteor shower activity and stuff like that. So check that out. You said you saw the moon. The moon's going to be new on Monday. Got a couple of moon things. Thursday, which is 14th. Oh, sorry, that was yesterday. Never mind. Let's see. Well, I guess the only thing we got coming up is next Thursday, the 21st, is the solstice.
Yes, let those solstice bells ring out.
Unfortunately, it's in the middle of the week, so we could either talk about it now or wait till next Friday. We will have a show next Friday, by the way.
Yes.
Everybody.
We're actually going to go pretty much all the way up to Christmas this year, aren't we?
Let's see. Yeah, well, Friday the 22nd we'll have a show, and then the whole week will be just music until after the New Year's. Yeah. Too many people on vacation, visiting family and stuff like that. So, I want to say hi to people down south. Friends in Australia. They've been having a heat wave there. 80s and 90s Fahrenheit there for us. Well, we have like 8s and 9s Fahrenheit, no zeros attached to it. So we get hot, they get cold now. It does that. That's what the solstice is about.
Shall we do this week's Sky at a Glance?
Let's do the Sky at a Glance, yes. And we'll talk about the solstice a little bit.
December 15th, the Sun Triangle sinks lower in the west. Altair is the first of its stars to go. Start by spotting bright Vega in the northwest right after dark. The brightest star above Vega is Deneb. Altair, this triangle's third star, is further to Vega's left or lower left. How late in the evening and into the advancing season can you keep it in view? There's a challenge, folks. As dawn begins to brighten on the morning of Saturday, the 16th, look very low in the southeast. Try and spot the thinning crescent moon. It's far lower left of the diagonal line of Jupiter, Mars, and Spica, which is off to the upper right edge here. So, have you ever watched a Sirius rise? Find a spot with an open view right down to the east-southeast horizon, and watch for Sirius to come up about 2/5 at arm's length below Orion's vertical belt. Sirius or Sirius rises sometime around 8 p.m. now, depending on your location. When a star is very low, it tends to twinkle quite slowly and often in vivid colors. Sirius is bright enough to show those effects especially well with binoculars. Sunday, this time the constellation of Ursa Major lies down lowest just after dark, due north. It's entirely below the north horizon, if you're as far south as Miami. By 11 or midnight, Ursa Major wheels around to stand upright on its handle in fine view in the northeast.
I want to read the next one.
Go for it.
On Monday, December 18th, the Pleiades star cluster, the size of your fingertip at arm's length, shines very high in the southeast after dinner time. How many Pleiades can you count with your unaided eye? Another challenge.
Yeah, take your time and keep looking. Most people can count 6. With sharp eyesight and a dark sky and a steady gaze, you should be able to make out 8 or 9. New moon, well, exactly new at 1:30 a.m. on the 18th Eastern Standard Time. Tuesday, the 5 brightest stars of Cassiopeia, usually called a W, at dusk. The W stands nearly on end, very high in the northeast. It soon turns over to become a flattened M, even higher in the north. Explore Cassiopeia's telescopic jewels. There are many. Now, you can get a copy of Sue French's Deep Sky Wonders article, chart, and the photos in Sky and Telescope's December edition, page 55. Wednesday. Do you want to go for that one, Starstorm?
Yep. This time of year, when M31, the Andromeda Galaxy, passes your zenith soon after dark, if you live in the mid-northern latitudes. The exact time depends on your longitude. Binoculars will show M31 just off the upraised knee of the Andromeda constellation's stick figure.
See the Big Evening Constellation chart available in all good astronomy magazines. Algol, the prototype eclipsing binary star, shines at its minimum brightness, magnitude 3.4 instead of its usual 2.3, for about 2 hours, centered on 11 p.m. Eastern Standard Time, 8:11 p.m. Pacific. You are remembered, Carl Sagan, 9th of November 1934 to December 20th, 1996. Thursday. Oh, let's put a shiver down my spine. Thursday the 21st. Yeah. Today is the shortest day of the year in the Northern Hemisphere. We will discuss the solstice More on our next show, which will be on Friday, the 22nd of December.
The
And
day
it's our
past.
pre-Christmas show.
Close enough.
Day past, but it's close enough.
Yep.
And, of course, Saturday brings Pychron and Sirius in balance.
Procyon.
Sirius, the dog star, sparkles low in the southeast, east-southeast rather. After dinner time, Pychron, the little dog star, shines in the east, about 2 fist widths at arm's length to Sirius's left. If you're around latitude 30, that will be Tijuana, New Orleans, Jacksonville. The 2 K9 stars will be at the same height above your horizon soon after the rise. If you're north of the latitude, Pychron will be higher. If you're south of there, Sirius will be the higher one.
There you go.
There we go.
All right. Let's see where we want to go.
Marty, before we go
Yes.
any further,
All right.
it is 9:30 or 02:30 hours, so you know what you got to do.
We could do a little station identification.
Yeah.
You are listening to the Event Horizon here on Astronomy.FM radio. It is now 9:30 in the evening, December the 15th, 2017, Friday evening for those of us here in the eastern portion of North America, also known as 2:30 in the morning, December the 16th, Saturday morning, 2017. Halfway through our program, and we've got a new Talking Space coming up, by the way, after this program. So stay tuned for that and more programs, too.
Right, now I'm going to say this very, very quickly. We are looking for more Sky Guides, more people to come on, do a recorded show, do a live show, whichever you prefer to do. Because you know what? We have Monday, we have York. Wednesday, we got yourself and Diane Marty.
Space Pirates.
And, of course, Friday, there's us with the Event Horizon, as we are now. And, of course, once a month, normally, we have Comet Watch. We've been a bit lax, I'm afraid, over at Comet Watch. Family issues and stuff have meant we've not been able to record for November. We are going to record a December show, which should be ready for transmission at the beginning of the year. Oh, one thing. By December 23rd, Mercury is emerging low in the dawn view where the moon was a week before. So something else to go look for in the early morning sky. It will be slightly above Antares and Scorpius. Yep. It's nice to hear the R's.
The laugh? The what?
No, the R. If you ever spoke.
I heard an R. R.
R, R.
Since you mentioned Comet Watch, have you kept up on a reported brightening of C216 R2 pan-stars?
Yes, I have heard about it. I just hadn't had a chance to get a telescope onto it. So,
yeah,
I'm doing a relearning program really, because I'm having to relearn a program called. It's by DreamWorks. It's a program that allows you to write scripts for telescopes.
Okay.
And it's kind of getting used to doing that, because the great thing about a lot of the remote telescopes is you can plug in your coordinates, your right ascension and declination, and tell them how bright or dim it is, and then click go. Some telescopes, you have to set up scripts to do this because they will list a series of bright comets, and that's about it. So if you want to go for something that's not on their bright comet list, you have to write a script, submit it, upload it, let them quality check it, and if the computer's happy with it, it'll execute it. And you'll get an email the next morning saying, "Hey Nick, we've got a photograph of your comet for you," or whatever object you decide to want to go to do. So yeah, at the moment I'm doing a major relearn. I'm also trying to learn PixInsight.
Mm-hmm.
Because hopefully after next September, I'm putting in a dome. I'm putting the telescope into a permanent mount. I'm going to have so much fun pouring concrete. Not.
Yes.
But the other thing I'm looking to get. Thank you, ACP. Thanks, Rob. I couldn't remember what it was called. ACP. Now, the other thing, of course, is I've got to learn 2 new cameras. One is the Attic 828 Plus, which is nice. It's got a nice big Kodak CCD in it. I'm just trying to figure out. Oh yes, Astro John's just come in and he said that they're collecting data on V452 CAS as it's currently in outburst.
Oh, interesting.
Yeah. Thank you, Astro John. Appreciate that. And thank you, Starstorm, for pointing it out to me.
I tried.
You do your job. But as I say, it's a case I'm learning this, and I'm going to have to bug Sky Guide Marlene for some information on Malancams. Because I'm serious. I like the new Malancam that's come out. It's called the Malancam Micro. But it is literally the great thing about Malancam is you can stream your telescope. Literally. To YouTube.
Night Skies Network.
Yeah. So you have the chance then to, even if you can't get into iTelescope or Sierra Remote Observatory or somebody else, I'm playing nice here, guys. The thing is, you can then stream your telescope. Obviously, aperture is everything. It does help. Even with a 10-inch Newtonian on GoTo on a Malancam, you can get some really great results.
Yep.
You can stream planets, you can stream the moon, and you can actually try and get some of the brighter nebulae and galaxies with it.
And maybe a flyby.
Dark skies help too.
Dark skies help too. Maybe it's time to take a few lessons from a few friends of mine. I've had various methods of taking out lights without destroying them given to me, from 1 million candle power flashlights through to laser pointers on the sensor. Apparently it's non-destructive. It just convinces the sensor it's daylight, I'm switching off. And it does work for about a few hours, and you got to do it again. Or you can just leave the laser pointer stuck on it, and it can completely think it's daytime all the time. But as I say, yeah, dark skies are nice to have. It's not too bad if you're doing the moon, because you can get away with it. And if there's a really, really, really bright comet, which I'm not really holding out for at the moment, maybe in a couple of years, if we're really, really lucky, then you can do that too. But the idea is it allows you to
Planets?
Planets. That allows you to share what you can see from your location. Not everybody can get to a star party, and if it's particularly if the weather is bad and it's a case of, well, Mr. X has got an observatory 2 time zones away, he's got clear skies, you can stream it. You can still have a star party, but you can do it online.
And inside.
And yes, you can be in the warm. I'm telling you what, minus 2 Celsius, minus 4 or 5 Celsius is not fun, particularly in upstate New York in the middle of the winter. Forget it. I'd rather run the whole thing out, have a remote control on it from my Radio Shack, and just sit there. I've got the radio on. I've got a nice rag chew going on all over the world, and I have got the telescope feeding to the internet. That is my idea of heaven. Well, some people say it's a place called Earth too.
Yeah.
Jung.
I'd rather the telescope streaming to me.
On a big blue marble.
From the telescope to me. That's what I want.
Yeah. That's the nice thing. The technology's there now. You can take a very good.
I remember taking a virtual field trip.
Yeah.
To a Canadian museum.
Yeah.
I think it was in Alberta.
Yep. But the thing is, we have the technology available. A decent 10-inch telescope is under $2,000. A laptop is under $500. You can attach your DSLR and run it to your computer or your laptop. You can get planetary cameras, which are basically hyped up webcams, attach them to your telescope, run it to your laptop, and you can stack AVI files. There's plenty of free software. You don't have to buy top-of-the-line software like PixInsight or MaximDL. Go with Fitz Liberator and Photo Elements.
Those are programs for correcting your images and combining them together to give you the best possible image.
Well, the nice thing is Adobe every now and again make some of their older software available on free and give out licenses. Mm-hmm. I've had CS for years, because what they did was the version that they've got had been superseded. They've got the new super duper version out. They were making money out of it, and they decided to put the previous version out there, the legitimate and free soft load from them with a license on the stipulation you were taking it on with no support, which is fine. You can get a book for that version. You can sit down, you can read the book, you can play with the software, you can learn it. But I always suggest learning.
That with Photoshop, though.
Yeah, Photoshop. That's exactly the program that was put out there. Now I got Photoshop back in 2009. It was free, and they were giving it away. You just told them what you wanted it for and who you were. They would email you a license. And the great thing was, I've still got that license. I can still get the software. And if I lose my hard drive, I just go to my backup drive and pull it off. Astro John is saying this is just what he does, but he doesn't stream. So we have the possibilities now of saying, if North America has an eclipse, a lunar eclipse, we can show it to the world. We don't have to rely on NASA, on TV. Well, yeah, get crowded out. That's it. You can be an asset. You can be a backup service for showing it, and that is really, really great, because at the end of the day, the official links get hammered. I went to the Keck webcast a year or so ago. They were imaging Saturn, and then their server just got slammed. They actually took it down 4 times and rebooted.
And that's what happens when people suddenly become interested.
Well, yeah, quite right. It was put out that they were going to make it available. They thought they'd covered the number of people who would log on. They got 5 times the number. Now, Astro John has said, why don't use AstroArt 6.0 and script image collection and do real-time pre-processing? He does that with a 3-star comparison and generates the BAA and AAVSO reports. Great idea. Astro John, drop me an email at nick@astronomy.fm, please. I'd like to hear more about that, please. Maybe we can get you on the show to talk about it. That would be brilliant. Because at the end of the day, this is what the show's about. People come into the chat room, they type into chat, and they put little pieces of pearls of information into there for us to talk about. So, Astro John, would you like to come back in the new year and join us for a show and talk about AstroArt 6.0 and how you're using it? Over to you, my friend.
All right, let's see. Series. Asteroid series. Remember, that's still going on with the Dawn spacecraft orbiting around Sirius. New research on the bright areas of Sirius, thinking that it's actually a little bit of some geological processes going on. A subsurface ocean, possibly. So maybe another spot to start looking for some potential life below its surface into the waters.
Well, yeah.
And be serious.
We all know about Europa.
Callisto.
We know NASA's and Callisto. We know NASA's going to Europa. There's a lot of competition out there to build a submersible that would go through the ice into the postulated liquid ocean that lies below. To search it for life. Now, whether it's going to be on a tether, I don't know yet, because nobody really knows. Oh, Astro John says sure. Great. Okay, what we need to do then is we need to get this sorted out so that we can get you on, John, and we can have a really great show. This is what this show is all about. As I say, Optronic says, won't Europa have too much radiation for life? We don't know. We just don't know.
And it's not necessarily going to be life as we know it.
Thank you. The thing is, on the surface, on the ice surface, probably yes. Underneath the ice, who knows?
There could be some dead biological stuff coming from underneath the ice and, shooting up and going onto the surface. So by the time it gets to the surface, maybe it's not alive anymore, but still could be remnants of life that would be analyzed. Frozen, for instance. So, a frozen bacteria on the surface of one of the moons of Jupiter, Saturn. Yeah, that's a pretty good indication. That would be pretty useful for an indication of life out there in one of the moons.
Hey, Marty, there's a question in the chat room. Why does Jupiter emit so much radiation?
Gas giant.
Because it's got a lot in it that's radioactive.
Well, one of the comments
planet,
from Starstorm was the gas giant.
It was possibly.
It has a huge magnetic field.
It's not so much the gas outer part as the core.
Yeah, it's
the radiation comes from the core. So it doesn't matter how big that gas atmosphere is around the core. It's the core itself which causes all that radiation. So it's got a lot of radioactive material in it. It sucked a lot of stuff up. And that's why it's got so much radiation. So the radioactive material, it got the most of it, of all the planets.
And of course, it traps a lot of the solar. I would have thought it would have trapped the solar wind as well, as it goes by in the magnetic field.
I don't think it's the same kind of radiation, though. So,
well, maybe
it radiates actually more than it receives from the sun as far as energy goes. So it's its own radiation source that's making it radioactive.
Yeah, but we know that it's got a very active core.
Mm-hmm.
And perhaps this is a question that Juno may answer,
mm-hmm.
or the next generation of Jovian missions would answer.
Mm-hmm. Got an article on the Juno mission, and it's recently released within a few days ago, 4 days ago, about the Great Red Spot. So they've kind of analyzed just how deep it actually is, and it's down a couple hundred kilometers, maybe 200 miles to 300 kilometers is how far they're thinking that the Great Red Spot goes into the planet itself. So they got equipment that can actually measure just approximately how far down it goes. So they said it's actually it's shrinking a little bit. Was it when Voyager went by? It was like 2 Earth diameters across. Now it's about 1.5 Earth diameters across. So it definitely is shrinking a little bit, but they still don't understand what's keeping it going, how long it's really been going. Basically, at least since the 1800s, when telescopes were good enough to see it, and it was then, figure it was probably before that, several hundred years before that at least. So it could be 400 or 500 years it's been around, but it's shrinking down. Does that mean it's going to stay shrinking down and fade away, or does it mean it's going to come back again better? Hard to say.
Okay, I've actually found an answer to the Jupiter question.
All right, well, I want to say that's one of the things that, now we've had a lot of pretty pictures from Juno mission, but this has been some of the real science coming out of the Juno mission. Go ahead.
Okay, so why does Jupiter emit so much radiation?
Okay.
I did a very, very quick Google on this. The answer I've got is, like the Earth, Jupiter has a magnetosphere.
Mm-hmm.
That's the region where the radiation from the sun and volcanic emissions from Jupiter's moons and ring interact with the magnetic field of the planet. This interaction creates a region of intense radiation, tens of thousands of times stronger than the Van Allen belts do here on Earth.
Yes. So it's got a strong magnetic field that traps particles coming from the sun. I think it's also internally much more radioactive.
It may well be. In fact, one of the things we would really like to know is, what is Jupiter's core made out of?
Mm-hmm.
There is speculation that it could be metallic hydrogen.
Because we know the planet's mostly hydrogen.
Yeah, when the most abundant gas in Jupiter, or in the Jovian atmosphere, is hydrogen.
So you can calculate if it's mostly gas, and that amount of gas and the amount of gravity, the size of the planet, can give an idea of how much mass, and get an idea of how much material would be in the core. Now, because it's mostly hydrogen, well, starting out saying, okay, maybe the core is mostly hydrogen, compressed down so much that it's basically turned into metal. But is there some actual metal there? Well, there's a lot of iron in the solar system. So does it have a fair amount of iron down in the core? Good possibility. Can we tell that? Maybe. But it's hard to tell.
One of the things I also just found was there's an answer here from Anastasia Windsor. She's an astronomer with NASA education. And they're thinking it's not really the planet that emits the deadly particles. It's the fact that it traps the highly energetic particles, be it from the sun or other interplanetary. Hi, Redshirt 3, and goodbye, Evil Spock. Look after Mrs. Evil Spock. I'm sure she'll be happy for that. So every planet with an active magnetic field, including the Earth, traps highly energetic particles within belts of the magnetic field. We have the Van Allen belts, which we are familiar with. Now, at some points of the magnetic field, the charged particles, either from the sun or wherever they come from, get trapped. The fact that they get trapped doesn't change the fact that they can destroy any biological system or electronic devices. The magnetic field of Jupiter is by far the largest of all the planets in the solar system. After all, it's a huge planet.
Yes.
And they're thinking this may be linked into the metallic hydrogen core, which is still a mystery. The magnetosphere extends millions of kilometers into space, all the way to Saturn on one end, and millions of kilometers in other directions. It's because that magnetic field is so intense that it's trapping these particles, and it's the greater amount of the charged particles are kept, be it from the sun, from Io. They literally keep accumulating, residing within the magnetic fields, forming the so-called radiation belts.
Okay.
Yeah, all the way out to Saturn. That is a record for any planet.
Yeah, that is a big one. That's definitely goes out to the outer moons of Jupiter too, especially. Did you see the launch this morning?
No, I didn't. I was at work.
I did get to see the launch this morning. It was SpaceX and Dragon Capsule launched to the space station. A bunch of experiments going up there. It was a nice launch. SpaceX, of course, that's the one where the first stage lands back down. It was at Cape Canaveral. So that's successful. Kennedy, yeah. Cape Kennedy at Cape Kennedy? No, it's Cape Canaveral, Kennedy Space Center. Yeah. But it's Cape Canaveral.
It used to be Cape Kennedy, and went back to being Cape Canaveral. And it flips and flops about. However, I do know that this is the first actual reuse of a capsule to the ISS with materials on board.
Okay.
Because this is part of the SpaceX program to literally reuse a spacecraft as much as possible. Yeah. Now, okay. Here's a question.
I think it's the second stage doesn't survive, if I recall.
The second stage doesn't survive, but the Dragon capsule has been reused in this.
And the first stage survives too.
Now, Marty, question for you.
Okay.
Is it possible that the ice on Europa was formed by nitrogen? There's a question for you. I'm keeping out of this because Starstorm has access to my books.
Is it possible that the ice on Europa formed by nitrogen? Meaning, is it made of nitrogen? I don't know. You'd have to check with the missions that have been there and analyzed it.
So okay, so this is something we're gonna have to look up for next week's show.
Yep, find out what it is. So
yeah, it was a great launch. I think the greatest thing about it is the fact that, as Redshirt 3 points out, it's available now. The launches are more available. We're reusing equipment and
letting it collect dust.
Well, rather than letting it drop in the ocean, never mind. It makes the whole technology cheaper.
And somebody has logged into chat.
Yeah. Aqua for Use just joined the chat.
And while you're watching the launch, and then the second stage goes on, it just becomes a speck barely visible. It gets kind of boring at that time. But no, you get to actually see the first stage come back down. That makes it more fun to watch.
Okay, question with a question. At what temperature does nitrogen freeze? That's from Glenn.
Liquid nitrogen. I know liquid nitrogen. Frozen nitrogen. Oh, I don't know. It's got to be, let's see, liquid nitrogen. Is that 180 below for liquid nitrogen? I can't remember. It's got to be around 320 would be my guess. That's just my trying to recollect. I'd say 320 degrees below 0 Fahrenheit is the temperature that nitrogen freezes at. What's the right answer?
Okay, it's either minus 210 Celsius or minus 346 Fahrenheit.
That's pretty close.
That's pretty cold.
Close enough.
That's like you can survive kind of cold.
Yeah, I don't think I want to be touching that. I've actually been in a laboratory when the dewar of liquid nitrogen has broken. Not fun, I can tell you.
I put my fingers into liquid nitrogen and had no ill effects. You can do that.
You can do that, but
yes, you can do that if you do it quickly.
Yeah,
a beaker of liquid nitrogen. You can actually dip your fingers in real quick because that layer of heat right around your fingers will actually boil the liquid nitrogen and keep it away from your fingers for a very short amount of time. So you can actually dip your fingers real quick into liquid nitrogen, pull them out, and not get a freeze burn. Now, if you left them in there, your skin would freeze off and it would freeze your fingers completely, and then you could hit them with a hammer and smash them to pieces, crystal pieces. But you actually can dip your fingers in liquid nitrogen very quickly. You just don't want to get it pour it down your shoes. If it, like you said, the beaker cracks and the stuff gets down into your shoes. Now that's bad.
That is very bad. Actually, the funny thing was, I was wearing a pair of rig boots at the time, and even I felt the cold. And the students were wearing trainers. One student had high heels on. And it was like, this is not funny anymore. Rig boots, you got a nice fur lining inside the boots. They're solid leather. They've got steel toe caps. Yeah, they can take it.
Well,
you might crack a bit of the stuff off the heels, of the soles, but that's about it. But it was like we were grabbing students and chucking them onto tables like nobody's business.
And then how much gets on the ground and how much you step in it and all that too. Now, if you happen to be a liquid metallic robot, it's really bad for you.
Yeah, this is like one of those very large dewars.
Okay, a whole dewar?
A whole dewar went. Okay.
Yeah, that could be bad because you're in it too long. It'll bounce off most things, but if you stand in it, that could be bad.
In fact, Redshirt 3 points out you can also dip your hand into molten lead due to the same effect. Mythbusters did it.
I think I read that too. Yep, I think I saw that.
Because Mythbusters did it doesn't mean you should do it.
Exactly. Thank you, Starstorm. Good point. They
are trained professionals.
Yes. Yeah.
Oh, we only got a couple of minutes left. Let's see. We got tons of stuff to talk about yet, but let's try to remember what else other topics I was going to go over. There were some good articles coming up. Just quick ones. We'll save them for next week then, actually. Like a new and improved method for measuring the masses of solitary stars.
Ooh, that sounds fun.
Yeah, the problem with solitary stars is you can look at the spectra and determine its color temperature, but you can't really measure the mass of the star because a lot of stars have that same color temperature to it. So one of the usual ways is having two stars orbiting each other. And if you get the spectra off of them, you can kind of get a closer idea of the sizes of them and comparing their masses by measuring their distance in orbit and stuff like that. But single stars were always really tough, but now they're getting a little bit better method for actually being able to do that. So we'll talk about that a little bit more and a few other things about how white dwarfs gulp down stuff. But anyways, I think it's time to...
This is the away team to the USS Miranda. Captain Savick, 3 to beam up. Quickly, because red shirt Marty has got himself injured again.
Green shirt today, no problem.
Good night, everyone.
Thanks, everybody, for listening in tonight. I want to thank everybody that's been in our chat room tonight. Appreciate it. Don't forget, we got more stuff coming up. Talking Space, a new Talking Space coming up, and more programs coming up. Thanks, everybody.
We won't leave you here. We won't leave you there quiet. You can join the beam out.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true. Every little bit counts.
AFM.
There I was, doing my thing. And all of a sudden, wham! Astronomy right between the eyes.